In Lesson 2-7, we're going to talk about writing an equation. This is mainly dealing with word problems and how to set up an equation to solve for a solution. So when we're translating to write an equation, it's a good idea to define your variable. That just kind of keeps you focused on what exactly are you looking for. Then write the equation using words in the problem. Sometimes that's very helpful. Use the operations with the variable. They do ask you to try and avoid using an equation where you equal whatever it is that you're looking for, equal the variable. Sometimes it's unavoidable, but we'll be looking at a few examples in class for that. And finally, you're going to solve your equation using inverse operation. So let's look at a couple of examples. In this first example, I'm showing you how to use words to sometimes help you form that equation. Here's the question. Ravi bought 3 identical shirts and paid sales tax of $2.84. Ravi spent a total of $50.18. So what was the cost of each shirt? So here I've written it in words. 3 shirts times the cost of each plus the tax equals the total that I spent. So now I fill in the numbers. The total spent was $50.18. The tax was $2.84. And I bought 3 shirts, but I don't know how much each one cost. So here I'm letting C represent the cost of each shirt. 3 times C. So now when I go to solve this, the first step would be to look and see which operations I'm using, multiplying and adding. So to solve it with the inverse operation, I would need to use the opposite of addition, so I would subtract, and the opposite of multiplying, so I would divide. Which one do I do first? Remember, you always undo any addition or subtraction first. So the first thing I would do to solve this equation would be to subtract $2.84 from each side of the equation. My second step would be to undo the multiplication by dividing by 3. So I'm hoping that you will come to school tomorrow with an answer of how much each shirt cost by solving this equation. Let's look at the one about votes. In 1976, Jimmy Carter received 58 fewer electoral votes than 5 times the number received by John Adams in 1796. Carter received 297 electoral votes. How many did Adams receive? So, both sides of this equation have to be how many votes Carter has, because we know that. We know that Carter received 297 votes. So equals 297. What's another way to represent that 297? Carter received 58 fewer. Remember from our glossary, fewer than means switch order subtraction. So minus 58, fewer than 5 times the number that John Adams got. So V is representing the number of votes that John Adams got. And that's what I'm looking for. So how would you solve this? Remember, we look at what operations we have, multiplying, subtracting. So we are going to do the opposite. We're going to add and divide. And we're going to do it in that order. So again, I'd like you to solve this equation and be ready to tell me how many votes did John Adams receive. Now let's look at our last 2 examples. In this one, we have tulip bulbs that we're buying. They're 85 cents a piece, and it's $3.25 to ship it. I have $17. So how many bulbs will I buy? So It's 85 cents a bulb plus the shipping, and I can't spend more money than I have. I only have $17. Now here is a type of problem where sometimes you will find that your answer has to be changed just a little bit. Let me give you an example. This isn't the real answer, but I'll give you an example. What if when you work this equation out, you get that you can buy 1.9 bulbs, tulip bulbs. Can you buy 2? Would you round that up? Would you buy 1.9 bulbs? You really can't buy a part of a bulb, can you? So even though it would be 1.9 and you almost have enough money to buy 2, you don't have enough money. So how many bulbs can you buy? 1. Now that's not the real answer here. I would like you to solve this problem, and yes, you can use a calculator, but solve this problem to find out how many bulbs can you buy. Okay? Now here's our last example. A zoo has an exhibit with harbor seals and sea otters. The number of seals is 7 more than twice the number of sea otters. If the zoo has 13 harbor seals, how many sea otters is there? So we know that there are 13 harbor seals. So we have equals 13. So how many harbor seals? The number of seals is 7 more. So that means plus 7. Okay, we could have 7 plus. It wouldn't matter where we have that, because remember, addition is commutative. 7 more than twice the number of sea otters. So I've let T equal my sea otters. So twice the sea otters, 7 more than twice the sea otters is the number of harbor seals. The number of harbor seals is 13. So now you're ready to solve this problem. So you would undo addition by subtracting, undo multiplication by dividing. Come to class tomorrow. Be ready to tell me, how many sea otters does the zoo have? All right, good luck.